Namaskar children. Today we are going to learn about a very important contact force, the force of friction. So friction is a force that opposes relative motion between two surfaces in contact. Now what do we mean by this term relative motion is, suppose I have these two paper cards here. If they are in contact with each other and they are moving together, we say they are not moving relative to each other. कार्ड 1 के हिसाब से कार्ड 2 मूव नहीं कर रहा और 2 के हिसाब से 1 मूव नहीं कर रहा. दे बोथ आर मूविंग टुगेदर बट फॉर ईच अदर दे आर एट रेस्ट. वी आर वॉचिंग दैट दे आर मूविंग. फॉर अस दे आर मूविंग. बट नाउ इफ आई स्लाइड देम ओवर वन एनदर, this is relative motion. Now card 1 is moving with respect to 2 and card 2 is moving with respect to 1. This is relative motion. Since friction is a type of force only, so the SI unit of measuring friction will be Newton. So according to our definition, till now we have understood that suppose this is a surface, say it is the floor, and we have placed a block over it, and now we want to move this block. So we start applying some force F. This is the applied force F on this block because we want to move it. We want to push it further. Now we are saying that when we apply force on this block, there is a tendency that this block will move. There is an impending motion. Impending motion means that the motion is pending. It might happen. The motion which is about to take place. So the impending motion will be in this direction. Friction is always going to oppose the impending motion. So this is small f, which is representing friction, which is a contact force. It will be between these two surfaces. The surface, the lower surface of the block and the surface of the floor. So this is friction which is opposing the motion which is about to happen. Applied force and force of friction are going to be in the opposite directions. It is this force of friction which is opposing the motion of this object due to this applied force. So we always label friction with small f in the opposite direction of the applied force or in the opposite direction of impending motion. Impending motion, I again repeat, motion which is about to happen, which is pending. Or you can say that this friction is opposing the relative motion between these two surfaces. The floor is at rest and the block, if it moves further, that will be a relative motion between the two, and this friction is opposing that relative motion. It is not allowing that motion to happen. Next, we are discussing the cause of friction. As discussed, there are minute irregularities on the two surfaces that are in contact, and these irregularities get interlocked. Now a diagrammatic representation is that suppose this is one surface having minute irregularities at microscopic level, and this is another surface which is going to be in contact with the first one. It also has minute irregularities. Remember, these are minute irregularities. They are not sharp endings as we were discussing in the last class. It's not that we will feel these irregularities when we walk on the floor. They are very minute. So these minute irregularities get interlocked, which are the cause of friction. So this is a pictorial representation of the same, a magnified view of the irregularities between two surfaces in contact. Let us now discuss the factors which affect friction. We'll start with an activity in which you have to create an inclined surface by placing 3 books like as shown and one inclined book, and you have to drop a ruler over it, say a dry cell or a piece of chalk or a pen, smooth surface, and we see that it covers a particular distance. Then we place a sandpaper on the surface and then we allow it to roll down and travel further, and we see that after placing a sandpaper on the table, it covered less distance as compared to the first case. This is because the sandpaper surface is rough, so the irregularities are more, friction is more. Now when I release this cell from this slightly inclined surface, you can see it covers a good amount of distance and stops after covering this much distance. On the other hand, if I release the same cell On a comparatively rough surface, you can see it couldn't cover much distance. Let me repeat. I placed the cell on this incline and it covers only this much distance. So this is because the nature of this surface is different. It's a quilt that I have kept here. So the roughness is comparatively more, or you can say the irregularities are more as compared to the marble floor. Another activity is that two bricks of different masses, say 5 kg and 2 kg, are placed on a table, same surface that means, and we will see that which brick goes the farthest on applying same force. So equal forces are applied on both the bricks, and we observe that the lighter brick, that is the 2 kg one, covers more distance, applied the same force. So this means that the force with which the two surfaces are pressed together also matters, that how much friction is there between the two surfaces. In the 5 kg brick, the two surfaces are pressing harder, the table and the brick, whereas in case of the 2 kg brick, the force with which the 2 kg brick is pressing the table is less. So we conclude the factors that affect friction are: 1. Nature of the surfaces in contact. So rougher are the surfaces, more is the friction, and smoother are the surfaces, less will be the friction. And the second factor is how hard the two surfaces are pressed together. More force means more friction, or the heavier brick, that means more is the weight, more was the friction. Difficult it was to move the brick. Let us now discuss the different types of friction. The first one is the static friction. It is the friction that exists between stationary object and the surface on which it is resting. So when an object is at rest and we start applying force, we are balancing it with the static friction. Remember, static friction is a self-adjusting force. There will be a point when you are gradually increasing the force on the object that the object will just begin to move. So at that point, the friction starts dropping. Once the object begins to move, we know it becomes easier to move the object. Then comes into play is the second type of friction, that is sliding friction. So sliding friction refers to the resistance created by the two objects sliding over one another. It is also known as kinetic friction or dynamic friction. The third type of friction is the rolling friction, which is the resisting force that slows down the motion of rolling objects. It is also called rolling resistance. Now remember, this is the relation between the three resistances or the three frictions, you can say. Rolling friction is the minimum, then comes the sliding, and maximum is the static friction. Let us now discuss the advantages of friction. Friction between pen and paper enables us to write on the paper. Friction between our feet and the ground allows our movements like walking, standing, and running. Friction between the surface of the road and tires of our vehicles allow the vehicles to move without slipping. So friction provides a grip to all these objects. So these are advantages of friction. Lighting a matchstick by rubbing. Nails and screws join two surfaces due to friction. We cannot climb a tree if there is no friction. Trains cannot run on the rails if there is no friction. So in fact, I have made a note that life will become impossible if there is no friction. We won't be able to hold objects, we won't be able to walk. So summing up the advantages once again, friction helps in walking, in stopping moving objects. It also helps in holding, writing, lighting a matchstick, fixing nail on the wall. And then the disadvantages of friction are shown here. You can see how the sole of the shoe has worn out and the tires are also wearing out. The grooves have smoothened. The stone steps you can see in the picture have worn out, and the brake pad in the vehicles wearing out. Disadvantages of friction. Friction causes moving objects to stop or slow down. Friction produces heat causing wastage of energy in machines. Also, friction causes wear and tear of moving parts of machinery, soles of shoes, etc. You might have noticed that the grooves of the tire become smooth after continuous use, or the soles of the shoes get worn out, or the stone steps get worn out after being used over a long period of time. Now, since friction has advantages also, there are instances when we need to increase friction, and this can be done by increasing the roughness of the surfaces in contact. For example, gymnasts apply some coarse material on their hands for a better grip. Also, the weightlifters do the same. The soles of the shoes are grooved to have a better grip on the floor. The tires of the vehicles are treaded to increase the grip on the road. So these are the three different examples where friction has been increased. Like you can see in this image as well, the grooves on the tires. The football players wear special shoes known as studs to have a better grip on the ground. Also, cricket players wipe the wet ball to increase the friction. Kabaddi players rub their hands with sand to get a better grip. And the sole of the shoes are grooved so as to have a better grip with the ground by increasing the friction. Keeping in mind the disadvantages of friction, there are ways in which friction can be reduced. Like first example is using rollers, wheels or ball bearings. You might have observed rollers are used in luggage bags to reduce friction, wheels are used in vehicles to reduce friction, and ball bearings are used in bicycle wheels, skates, fans, etc. Another way to reduce friction is by using lubricants like fine powder, oil, or grease. For example, we sprinkle fine powder on a carom board to reduce friction while playing. Oil or grease is applied between moving parts of machine to reduce friction. So here it is shown lubricants being applied and adding wheels and using ball bearings or polishing the surface. How does it help in reducing friction? So up till now we were discussing friction on solid surfaces. Now let us talk about fluid friction. Liquids and gases are commonly known as fluids. Now, whenever objects move through fluids, that means whenever objects move through liquids or gases, they also oppose the motion of the object through them. This resistance to the motion of object through fluids is known as fluid friction, or also known as drag. Let us now discuss the factors on which this fluid friction depends. The first factor is the speed of the object. More is the speed of the object, more will be the fluid friction. Less is the speed, less will be the fluid friction. For example, a speedboat will face more friction as compared to a paddle boat because a speedboat is moving with a greater speed. The second factor affecting fluid friction is the shape of the object. If the object is streamlined, which means pointed from the front, they face less fluid friction. And if it is not streamlined, it experiences more fluid friction. And the third factor affecting fluid friction is the nature of the fluid. That means if the fluid is more viscous or thick, there will be more friction. For example, moving an object through honey or glycerin, these fluids are thicker or more viscous than water. So moving an object through these fluids would be difficult as compared to moving an object through water. So these are the three factors on which the fluid friction depends. Now let us learn how we can reduce fluid friction. Fluid friction can be reduced by streamlining the shape of the vehicle. This is done by making it pointed from the front like a bird. Like you can see in the image, a bird and an aeroplane have a streamlined body, hence they can move through air easily. Similarly, a ship or a motorboat has a streamlined body so that they can move easily by cutting through the surface of water. And also, cars are designed with a streamlined body so as to overcome the air resistance.